In this video, we will find the number of combinations using the combinations formula. So let's just review what that combinations formula is. So when we are selecting objects from a larger group of objects, and that order that we're selecting the objects in doesn't matter, that means we are dealing with a combination. Order does not matter. So we're given n distinct objects, so all different objects, so we have n. And the number of ways to select those R objects is given by this combination. N choose R is how we say it. Sometimes we see it written like this and sometimes like this. They both mean the same thing, and you can calculate them both using your calculator. This is the formula to use by hand. N factorial divided by R factorial times N minus R factorial. So this is when order does not matter. You're not specifically arranging things in order, like a playlist, or assigning roles like president and vice president. This is just, hey, I know I want to read 5 books out of these 10 books. How many different groups of 5 books are there? Not a specific order. You're just choosing kind of a chunk at a time. Let's see what that looks like applied. Given that there are 6 different flavors of ice cream at some ice cream parlor, how many ways can you select 2 scoops of different flavors of ice cream? So, you want a cone that has a double scoop on it and there's 2 to choose from, and you want 2 different flavors on your cone. So how many ways can you do that? The order in which you eat the 2 flavors does not matter. You just want to know how many different groups of 2 are there. So defining N and R, N is our total number of objects, 6, and R is how many objects we are selecting, which is 2. So we want 6 choose 2, which is 6 factorial divided by 2 factorial times 6 minus 2 factorial. So you might think it's pretty similar to a permutation, except we are adding this additional piece to the formula. So we're actually dividing by something extra, which means we're going to get a smaller number because we're not accounting for order. So there's actually less answers, or there's less ways to do this. 6 factorial, which is 6 times 5 times 4 times 3 times 2, and I'm not going to write the 1, times 2 factorial, which is 2 times 1. And then this right here is 4 factorial, so we have 4 times 3 times 2 times 1. And then we can see what simplifies here. Now note that you can plug this into your calculators. You do not have to do it by hand. Okay, so that cancels out. And then we have 30 divided by 2, which is 15 different ways. So there's 15 different ways that if you are at an ice cream parlor with 6 flavors and you want to put 2 on your ice cream cone, you can do that in 15 ways. Not thinking about which one's on top and bottom, because if you cared about which one was on top and bottom, guess what? There would be more ways to do that, right? So there's less combinations than there are permutations, because we don't care which one's on top and which one's on bottom.